Hello, everyone. It's time for our panel. We've got the whole house here. Thank you so much, Janahan, Patricia, and Monsi for joining in. We're very pleased to have you. So this panel is about big data and analytics, which are a central component for modern enterprise networks. Organizations in industry and government, as well as academia, deploy security operations centers, which ingest large streams of data to manage network operations, defend against cyber threats, and maintain regulatory compliance. This data comes from various sensors, which include routers, your network endpoints, operating system logs, access and authentication loggers. The structure and the scope of analytics performed are often determined by the size of organization and other organizational specific aspects, such as services it offers to its users or its domain of activities. SOC is still at the core of this, and it's fueled by big data. So in this panel, we have a very interesting mix of folks who have experience working in different areas. I'm going to be introducing those, and it would be a brief introduction. All three are very well known in their respective areas. At a high level, our goal would be to learn about various aspects related to big data and cybersecurity, how this data is processed using AI and machine learning techniques, and what future holds for big data and analytics. With that, I'm going to introduce these leaders in cybersecurity. First, we have Janahan. Janahan is a Senior Director of Research and Development Arctic Wolf Networks, and he's responsible for the security intelligence, security research, and security analytics mandates. He has held senior roles in both startups and enterprise organizations, including Motorola, GE, and Telus. At these organizations, he led global engineering teams with a career track record of designing and developing innovative systems and products. We have Monsi Mirza. He serves as the VP of Cybersecurity Go-to-Market at Databricks. He's responsible for driving Databricks' cybersecurity business strategy. And before this, he was a VP at Splunk, as well as a security researcher at the US government. We also have Patricia Thane, hopefully soon to be a doctor. She's the co-founder and CEO of Private AI, currently a computer science PhD candidate at the University of Toronto, where she does her research on privacy-preserving natural language processing with a focus on applied cryptography. She's a recipient of several prestigious scholarships and has 8 years of research and software development experience. It's a pleasure to have all three of you. I'm really excited about this panel. Thank you so much for taking time. So we're going to start with a little bit of background, especially for those joining us who are not so well versed with this area. So Janahan, my first question would be from you, and it would be great if you could elaborate that what are some of the most pressing problems that exist in cybersecurity and privacy?
Yeah. So I think a place to start is what and where cybersecurity is today, and what domains or areas does it encompass or impact, and where it is needed. In terms of where it's used and what cybersecurity percolates through, businesses is one of the key aspects, because that's where the money is, right? So from a cybersecurity perspective, on the business side, you have enterprises and SMBs, right? Each has their unique facets and their unique challenges. Enterprises, they're a hot target for ransomware attacks, phishing attacks, insider attacks, and business email compromise, to name a few. The challenges with enterprise today is that the time of perimeter security is pretty much dead, given the distribution of devices, bring your own devices, and so forth, that enterprises basically use. So it's all moving towards zero trust security. The other thing with enterprises is they usually have legacy systems that need to be modernized, and that brings in a different cybersecurity vector there, in terms of a vector that that malicious actors can target. Then there's the asset and inventory management aspect of enterprises as well. Following the adage that you cannot secure what you cannot see. And then large enterprises usually go through a lot of M&As in terms of mergers and acquisitions. So even if they were they had good cybersecurity hygiene, the ingestion of different organizations with their specific cybersecurity postures, changes the enterprise. Can basically bring in that vector into the enterprise as well. And then there's of course the supply chain security, which affects quite a bit of businesses, because the visibility into supply chain security is not quite a mandate of, you could say it's not quite the mandate of enterprises per se from a business perspective, and it's more to do with those that contribute to building the supplies that form in the supply chain security, right? Then you have the SMBs on the business side. They are basically they're not staffed for security. Their primary focus is not security, because they have a primary focus on certain business aspects, which is why they're a small and medium business. They have an inadequate understanding of security issues, and that's the challenge for SMBs. But they are they're a good low-hanging fruit for malicious actors, especially in terms of ransomware attacks and so forth. That's been seen of recent origin. Then the other aspect in terms of problems in the problems in cybersecurity are basically supply chain security. So in terms of the recent attacks, the SolarWinds attack and the NotPetya attack, you can see that supply chain security is a very pressing problem in the industry right now. Backdoors and open source libraries have contributed there as well, and that remains a key aspect of issues that develop with regards to cybersecurity. Now, with regards to how this all gets threaded together, whether it's regards to businesses and businesses being the entities, all entities from a cybersecurity perspective, to actually reach those entities, you would need the actual carriers, the network, the networks that carry the data, that give access. So from that respect, you have the telecom carriers and the SCADA and ICS systems that basically support the critical infrastructure of a nation, and that is another area where there are a lot of problems from a cybersecurity perspective, in the sense that they're all SCADA, ICS systems and carrier networks. They're always the target of attacks from nation state actors and organized crime. And the intent here is not money, and from a perspective of ransomware and all that. The intent here is to basically disrupt. So there are motives other than money. There's politics and various other issues there. And then we've seen this through past attacks, such as the Stuxnet attack, the attack on the Ukraine power grid, the Colonial Pipeline hack, and most of the issues that we're seeing in this respect is basically that as more of critical infrastructure and SCADA and monitoring systems get connected to the internet through IT and OT integration, you basically introduce new threat vectors into that respect, right? And then last but not least, going into more of where the industry is right now, with regards to future and all that, with how we're planning to become more connected from smart city and intelligent transport systems, and the proliferation of IoT devices in the billions to trillions. That's going to generate a large amount of data, which would help with big data analytics, but it increases the attack surface. There's more P2P architecture. There'll be more physical attacks because it's out in the open, with autonomous vehicles and so forth. And signature-based approaches that we have today just won't scale, because there'll be customized devices, and they're inadequate security controls for IoT devices. So that, in a nutshell, is a number of problems that exist right now in the cybersecurity space.
That's very helpful. Thank you so much. I think you've covered the breadth very nicely. Really appreciate it. Monzi, would you like to add something to this?
I would just maybe go take a look at it from the enterprise's perspective. I've worked with a lot of customers, and I just want to call out maybe very briefly the trend that we're seeing. Well, actually, before I get into that, first of all, thanks for having me on the panel, and it's really nice to meet you, Hassan and Janahan and Patricia, and thanks to TMLS for all the attendees who are joining the session. And I just want to call out one data point. When I started in this industry, maybe almost 20 years ago, and people used to say big data. In those days, big data was measured in the tens of gigabytes. I recently, just like by recently meaning a couple hours ago, got off a phone call with a customer, and they told me about their big data. 115 terabytes of data per day that they're collecting from their cybersecurity infrastructure, to Janahan's point of getting visibility for their endpoints or detection logs, DNS logs, and so on. And so I just want to put that in contrast when what enterprises are now struggling at, and why machine learning and artificial intelligence as new techniques are so needed, is because just the scale and volume of things have completely changed. So if you hear a vendor talk about big data today and you say, oh, I've been hearing about big data for a while, it's a completely different ballgame. And the other thing that's happening from an industry perspective is organizations have shifted now, or starting to shift from on-prem to cloud. And we used to say, 2 years ago, no one's going to go to the cloud. Well, that ship has sailed. Everybody's mostly in the cloud. And now we're seeing another trend, which is it's not just cloud, it's multi-cloud, because organizations are trying to bet on the major cloud vendors based on the product and services that they have. So big data is huge data, or we need a new term. And then it's the multi-cloud that's pushing all of this. And as a result, all those things that Janahan talked about, those have persisted over some time, but now they're even more crazy to manage because it's ridiculous scales.
That's very helpful. Thank you for sharing that perspective. I think that puts things in the right context. Patricia, I see there was a lot of focus on security, at least no privacy talk from consumer standpoint. What, in your opinion, are some of the pressing problems, at least in privacy domain?
Yeah, great question. And I thank you also for having me, Hassan. Really happy to be here. Also great to meet you, Janahan. So they really go hand in hand, right? If you don't protect your users' data, if you don't have proper security in place, you're not going to have privacy. And where privacy really comes in is thinking through what kind of constraints you need around your users' data, what kind of permissions you need for people to access your users' data. And it really helps put things into perspective about what's the minimum amount of information that you need to collect in order to do your job. And what we're seeing with the most advanced organizations when it comes to thinking about GDPR compliance is they are thinking about data minimization. They are thinking about how that data is spreading throughout the organization and minimizing the amount of data that a data science team has. For example, if it's customer chats with, for example, social security numbers, they're going to want to remove those social security numbers before they send those to their machine learning teams. So there is a lot more awareness and the major blocker right now to getting to that level of security, that level of privacy, is understanding what kind of personal information is in the data that you're holding. And that's really important because if you don't understand what kind of information your data is holding, you're not going to know what parts to protect. And what you're going to need to do that is AI for the most part, because 80% of the data that we produce is unstructured data. You're not going to be able to use a regular expression to determine that somebody's credit card number was mentioned in a transcript if that credit card number is mentioned in pieces between a bunch of different conversation elements. You're also not going to be able to use standard techniques that don't require AI when it comes to detecting whether somebody's face is an image. And whether there's a credit card number that's written out that you need optical character recognition for in PDFs, things like that. That's really where there's a big marriage between privacy and cybersecurity and security as a whole for the data sets that people are collecting.
Thank you so much. That was very helpful. Monsi, I would like to connect with you again on the point of the amount of data that you mentioned. I think not only puts things in perspective, but also it's scary. If you get that much data per day, that is a problem on its own, I feel. And how do you think we can use big data and analytics on such large amount of data to solve some of the problems that Janahan pointed out?
I think there is, yeah, the data volume is kind of crazy. Maybe I can use like a physical illustration. Like, here's a phone in my hand. This has about a half a terabyte of storage on it. And if it's 115 terabytes from my last customer conversation, just imagine that like 6 of these phones just fly in your direction approximately every hour, right? And somebody's like throwing this thing at you. So now that, because we say terabyte, and what is a terabyte? So now it gets a little bit physical. So now you can imagine, how do you calculate and how do you like actually analyze this amount of information? And then how do you secure it too? Because even for cybersecurity visibility purposes, when you collect that data and then an adversary gets on top of that data and has access to that data, now you create a whole other set of problems for yourself. And so that's sort of the data collection and data storage problem. And that's why a lot of the cloud providers and a lot of the customers, are offering services for data storage. And a lot of customers are actually moving to the cloud. It's kind of a self-perpetuating problem, moving to the cloud such that they can store that kind of data. And part of the reason to store this, if you go back to the 115 terabytes, if you analyze that and maybe go to 13 months, which is a regulatory period for many banks and services, that 115 terabytes per day is roughly like 45 petabytes of data over a 13-month period. And there's a lot of intelligent people on the chat. If my math is off, somebody can help me with that one. But it's a lot of data. It's 45 petabytes. So now, but why store 45 petabytes? I think is a root question, right? And so Janahan mentioned a bunch of these threats, whether it's Stuxnet and NotPetya or other ones that you can sort of Google. And it takes on average about 200 days for any of these breaches to be detected, like post-breach. The attacker gets in your environment, it takes about 200 days. And you can sort of Google for these numbers, and there's multiple reports, and most people sort of converge on this 200 from time of breach. So you have to hold 200 days worth of data if you want to have a chance to detect. Then if you look at some other studies that point out that it takes anywhere from 50 to 60 days after detection to work that breach to some level of confidence and conclusion, so that you can go back to the regulatory authorities, you can go back to the customers, you can go back to law enforcement. So now we're at roughly, let's say, 260 days. So that volume of data has to be stored for at least that long so that people can have some confidence around it. So what's happening now, it's creating this necessity for organizations, not just for storage, but now for this necessity to analyze that data, not just historical, when somebody shows up to you and says, well, here's a pile of indicators of compromises. Here are some IP addresses, some usernames, and some domain names that have been breached. Can you see if we've been impacted? And now you have to go sift through this information. So that's a post-fact kind of analysis. There's another kind of analysis now that's happening on these large data sets, where you have this streaming volume of information that's constantly coming in through your networks. DNS records, authentication information, customer transactions that are happening in an application somewhere. And all of that information is streaming, and you want to detect the threat as quickly as possible. So now you have to enrich that information with additional information, and you have to run some sort of analytic on this information. So that's how it's starting to manifest themselves. And I share like a specific story with you, also from another customer, from a large financial services institution, who said after they discovered that or heard from some of the vendors about the solar flare attack, which was a supply chain attack in the SolarWinds software, which is used by many organizations. They went to, and they were SolarWinds customers, they wanted to figure out what was the impact and how many of these things they have in their environment. When they went down this path, after figuring out what it's going to take to actually execute the analytics, I see some grad students on here and some computer science people, right? So they can probably talk about automation and analytical competency, right? It took them 14 days to go across their environment to just search to see if this was possible or not. So there is a big challenge here and a big opportunity to do this. And then to tie it back to Patricia's point, if you are responsible for customer data and you have a breach in your environment, and even in that case, for 14 days, you're in the lurch just to know whether you've been impacted or not. And that has nothing to say about what customer data potentially would have been stolen as a consequence of this breach, and what are the second, third order effects of that, whether people's credit card information got stolen or their other personally identifiable information got stolen. And in those 14 days, there's such an underground economy to materialize stolen information, to where from the time it takes to acquire the information to where somebody either creates a fake credit card using that person's identifiable information, or walking into a bank with a fake ID with my picture, but it says Patricia on it. So when they validate it, they say, "Oh, you're Patricia, sure," and they let me cash out money at a bank teller, right? So those ramifications move very, very quickly.
That's really helpful. Thank you so much. Janahan, would you like to weigh in on this part as well?
Yeah. So, I mean, when you stated in the question, there's so much data, how can we use it to address the problem? So one of the things in big data analytics, especially with its intersection with cybersecurity, we want more data. It's not that, the more data, the better. Now, sure, from an infrastructure perspective and, with regards to handling the data, there are going to be issues there. But what's the other alternative? To help with cybersecurity analytics in terms of, like, I can talk about some applications on where we use big data analytics for cybersecurity and where it's being used in the industry right now. There's data-driven threat hunting. There's threat intel extraction, right? Using machine learning on data for extracting threat intel. Then there's the, from an active standpoint, we want to do continuous detection, which is continuous analytics, streaming analytics to basically detect threats. Continuous risk evaluation. The only thing that can help us, and the only thing that can better our ML models, is data. So we need the data, at this point in time, I can't think of any other way to basically counteract the malicious actors that we get from a cybersecurity perspective than through advanced analytics on vast swaths of data in an extremely efficient and fast manner. And that's the opportunity you could state from the perspective of we need to get there fast, and the demand for data will only increase because the more data we have, again, quality data, there's definitely there's quantity and quality, but with respect to that, we need lots of good quality data to keep us one step ahead of malicious actors.
That's very helpful. Thank you so much. Patricia, feel free to jump in.
Thank you. Yeah, that's a great point, Janahan. And what I've heard from several parties is different organizations have access to all this information about these threats that they're overcoming. And what would be really helpful to them would be if they share the information with each other. But there is this hesitancy between enterprises to share that information across competitors. So this is another aspect where if privacy-enhancing technologies were used, these organizations could get a step ahead together. So something like secure multi-party computation to allow them to perform the computations without knowing what the inputs are, but knowing what the resulting output is, or federated learning. So training the machine learning models on each of these enterprises' individual servers and then combining the results together could lead to that better data that is necessary for the industry to advance.
That's very helpful. Thanks. Monsi, my next question is to you, and I'm going to thread in a question that Nigel has posed right there as well. When this data comes in, the understanding is there's something called data lake where all of this data goes. Now, regarding this data lake, first, it's a place where we're going to run our analytics on, but on top of that, who is going to be the prime consumer of this data lake? Also, where does this data lake exist? On-prem, on cloud? Is one strategy better than the other?
Yeah, I think I'll share with you the patterns, and I think it's up to the organizations to decide, but based on what we're learning, right? And maybe from a cybersecurity point of view, this term data lake for some, for many cybersecurity operations teams, perhaps is a new term. And another term that's evolving now that we're starting to hear more and more is the concept of a lake house, where you're marrying these concepts of data lakes and the concepts of data warehouses and pulling those two pieces together. And the security operations people kind of have to wrestle with these concepts and what's happening from a tech perspective, all the while trying to maintain, step with what's happening in the threat landscape too. So we kind of have this dual. I don't envy the practitioners of today. I would, if I put my old man hat on and say, in my day, it was not this it was hard, but it was not this complicated. So I have a lot of respect and empathy towards the modern security operator. On the data lake side, what we're seeing with customers is where it's emerging from is a lot of organizations used to use monitoring solutions or log aggregation solutions or SIM solutions to bring security related data into their environment, so then they could gather alerts and then they could sort of and they can do detection and they can do triaging and so on. And those were sort of custom built solutions, primarily closed box style solutions. And they had kind of their limits. And so data lakes kind of started out initially with the emergence of Hadoop, where they said, just put all your data in one place or just collect it all as cheap batch storage, and you can just have it there and you can utilize it. Well, so that's one style. And then there's these data warehouses that were really fast at doing certain types of, usually in the relational database style world, really fast at certain types of calculations. And so people are saying, well, you have business logic or business data, you put it in here so you can service your customers and do things very, very quickly. And now as security operators, we're looking at this world going, well, actually, I need both. I need to run analytics really, really fast, and I need to go back in time, and I need to hold storage, and I still need to manage my cost. So that's where this merger of data warehouse and data lakes is happening. So now that we have that kind of base foundation, now we say, well, what are customers doing? And where is it happening? So one example is, of a customer, we work very closely, one of the largest oil and gas producers in the world. They have basically established Databricks' Lakehouse as their primary landing spot for all of their cybersecurity related data and also a lot of their business related data. So they're doing everything from collecting DNS logs and their customer loyalty cards that people use at a gas station, and capturing that data there. And that really has some privacy ramifications, I think, for Patricia, where you're kind of almost commingling, at least in concept, but not really commingling from a tech perspective, but at least in concept, it's in the same place. And what they're doing from there is they're trying to detect, they're basically using this business data in the loyalty card example for cybersecurity purposes, because now they can do that because it's not a proprietary system just for cybersecurity. So now they can detect fraud. Now that they can detect if somebody's loyalty card has been stolen, or as a consequence of somebody charging money against their cards, right? So those are the kind of use cases now being utilized to improve security. The other thing that's happening because of this marriage and because that you can start to enable machine learning capabilities on top of this, now we've gone from a detection and investigation point of view that Janahan alluded to, not just from a rules-based system where you say how many counts of something or find this specific name or this specific domain to be bad, from a machine learning perspective, to utilize more sophisticated logic, whether it's doing enrichment and clustering and doing anomaly detection all in one stream from a detection perspective, or doing it in an automated way. Another sort of different oil and gas customer, what they do is, Janahan mentioned ransomware. They're really passionate about ransomware because if that happens in their environment, it doesn't just impact them, it actually changes the price of oil in the world. And so it's a huge impact. And so what they do is every time there is PowerShell executions, if somebody's using PowerShell in the Windows environment, for example, and uses PowerShell anywhere on an endpoint in their environment, they collect that information and they automatically treat that as a breach and run an automated investigation on top of the Databricks platform so they can enrich and automate a whole bunch of different things. So what would take hours and hours for an analyst to do, now it's being done by a machine. And the benefit of that now is that the human being is actually teaching the machine how to do things faster rather than stitching things together and going through these mundane tasks. Where are they doing all of this kind of stuff? They're doing it primarily in the cloud, because on-prem systems by and large, or on-prem infrastructures by and large, are not prepared for this sort of flexing of an environment where, the Christmas time is coming and a lot of retailers will see a spike in utilization. You can't you can't have this CapEx deployment of a whole bunch of hardware that sits there for 8 months out of the year, and all of a sudden after Thanksgiving, around Thanksgiving, spikes up. So it's primarily happening in the cloud. And the other shift that's happening, where before it was security in the cloud because people were using these advantages of cloud cost models, now it's becoming security of the cloud because their application or services themselves are running in the cloud. So they're using cloud capability to protect cloud capability.
That's really helpful. Thanks. I think this is very much related to it. Nigel has asked that, going back and touching on the scale of big data. Nigel's question is the key here to categorize the security considerations based on how much of that data needs to be dynamically used, retrieved and interrogated, or purely stored for possible or probable future reference?
Yeah, I like to think of it, or at least a recommendation that I give to customers and what seems to work is that I like to start from the use case rather than starting from the data. Because if you start from the data, that can become a very exhausting journey. And so if you start from the use case to say, okay, just like this ransomware example, for instance, or Janahan mentioned supply chain attacks, a couple of times, is that focus on the use case that is valuable to the business. Or if privacy is important and you're a bank and your customer data is super important to you, start from that use case and then say, what are the data sets that are required in order for me to provide some level of confidence and resilience and assurance around my operation? That's potentially one path that you can choose. The other path to choose is to say, well, I'm in a regulated industry, and my regulated industry already, it has these requirements that they've levied on me. And as a consequence, I'm going to implement these use cases. And for that implementation, I need these kinds of data sets. And I think this is really what's kind of manifesting this emergence of this lakehouse concept from customer, or this demand for lakehouse from customers is really embedded in Nigel's question, in that organizations want to do the streaming piece because they have requirements, and they want to use this batch piece because they want to hold the data for some reasonable amount of time, so that because they know bad things will happen, they can actually go back and understand and assess the damage. So apologize for being vague, but it's at some level, the answer is both, and that's what customers are doing, and that's what's necessary.
Thank you so much, Janahan. Would you like to weigh in on this?
Sure. So I mean, to your first, I'll get to Nigel's as well, but to your first question on, the prime consumers of the data lake, what we're seeing is, so firstly, it'll be everyone in the line from detection to response. So you'd have your data science team, obviously the data analytics teams that comes up with the analytics for detections. You'd have your threat hunting team that, hunt threats and so forth. You'll have your incident response teams. You'll have your SOC. Then you'd have your certain R&D teams as well for audit and compliance requirements, including privacy requirements, because that also applies when you have the cybersecurity data lake, right? So in terms of the prime consumers, it is that entire line. Plus, what we're seeing is more and more, as cybersecurity itself, like many other disciplines, becomes completely data driven. It's just going to increase in terms of the different teams that basically that'll become the prime users of the cybersecurity data lake. With regards to about on cloud or on-prem, I see everything moving towards the cloud because of the advantages there and the disadvantages with on-prem. I mean, from a cloud perspective, as one of the aspects that Mansi mentioned, the advantage is it's extremely elastic in terms of what your resources, what you have access to, and so forth, right? You have serverless and managed services type architecture. And the other thing is it's extremely reliable, right? I mean, if you look at the public cloud providers, I mean, what's the probability that you're going to get that, the reliability aspects there compared to something that you have on-prem? Plus, with the large providers, if one of us is having a reliability issue, there's quite a number of us who will be having that issue. So from a business aspect as well, it balances out. But the public cloud providers, they're extremely reliable in that respect. Some of the disadvantages there, it wouldn't be disadvantages, but privacy does come into this now, because when you put everything on the cloud, data sovereignty issues, right? Different nations have different data sovereignty laws. So, you know, where the cloud is located and all that matters, physically located. One of the issues that we're seeing in cybersecurity today is the latency issue, which, you know, I'm pretty sure will be taken care of soon as time goes up by. And that, by that I mean, you know, with regards to threat detection, which is extremely important for cybersecurity. If you do the analytics on the cloud, you know, no matter how fast the cloud is, you're still connected to the cloud through the network carriers. If there's latency there, and you're doing a detection on the cloud and sending the information back, then obviously there might be delay. There's possible latency in terms of affecting an action to protect against a threat. Right. And with regards to Nigel's question, I would say both, because one of the key aspects that we've noticed in cybersecurity is there's no data, and I've seen this, you know, realistically in practical items as well, in practical purposes as well. There's no data that you could tell at this point whether you would need it in the future or not from a cybersecurity perspective. There's always, in terms of data, there's always something that's there, and there's a high probability that if you throw it away now, that you'd probably regret it later. So just using it for, you know, at the moment from a dynamic perspective, and then making a decision between certain pieces of data being dynamic and certain that, well, you know, we don't need it right now, and if you don't store it for a future use, especially from a big data analytics perspective that looks at historical aspects to see patterns and so forth, you will regret it later. So I would say both.
Thanks, very helpful. Patricia, we've been hearing from both Monzi and Janahan about why there is a strong need to have this data lake on the cloud. Do you think there will be privacy and compliance issues with the security data lakes on cloud? And if so, how can we get around those issues?
Yeah, that's a great question. And it really depends. As Monzi said, you have to start with your use case. So starting with your use case is super important. According to various data protection regulations, you have to get a positive consent from users when it comes to determining exactly what you're going to do with their data and what kind of data you're collecting from them. And a lot of the tools out there are starting to make it possible for companies to be able to organize that data. Also starting to make it possible for companies to be able to associate specific personal information with an individual. So things like access to information requests become more easy to do, as well as requests to be forgotten. But there is still that big problem with unstructured data and how you handle that, because it's much more difficult to look into a PDF and say this person's personal data is there, but much easier if you're dealing with structured data specifically. But ultimately, where I see this going is more and more we're going to move towards privacy towards the edge. The best thing that you could possibly do is minimize the amount of data that you're collecting from an individual for your particular use case the moment that you're collecting the data. And that takes away a lot of the problems. One, the sending personal data in transit, even if it's encrypted, you're still going to be decrypting it in the cloud at some point or another. It also takes care of the problem of latency because you're using users' devices, these terabytes of data, and you don't have to rely on your company cloud to process that data. And also, it's a cost sink. And in addition to that, there is one more aspect that these data lakes are going to have to solve, and it's really being able to dig deeper into this unstructured data for not just data minimization, but also for detecting where the personal information are stored. And those are two pretty different things, but pretty much the same technology. And the speed at which machine learning models are adapting to GPUs and becoming smaller and smaller and also more accurate is really allowing us to go towards that sort of world where we can reasonably process terabytes upon terabytes of data in a relatively short amount of time with relatively short compute costs. And that's something that we work a lot on at Private AI, specifically for text and images as well.
Thank you so much.
Thank you.
It's a very interesting discussion, but it seems like we have a very little time left. So I'm going to just be a little more focused. Monsi, there was in your last response, you mentioned something about data warehouse architecture, data lake architecture. In all of that context, there is a new term that is lakehouse paradigm. Could you explain that a little and how it helps in design of a scalable security operations center?
Yeah, so at a very high level, the concept basically is that the lakehouse architecture takes the best capabilities of data lakes, which tend to be open, that can store data in a less cost of in a cost manageable fashion, and that are integratable, right, as a consequence of being open with lots of technologies. That's a very powerful aspect of data lakes, and that's why they caught on. And then the capabilities of data warehouses, which are really good at transactional compliance, and if you look at the term asset transactions, so that you can manage concurrency, you can manage integrity of the data, and so those are sort of the two capabilities that two of many of each one of these two systems. And the idea is that we want to be able to combine them, because and this really goes to the heart of Nigel's question, is you want to hold this batch data for long periods of time in an economical way. And so therefore you want a data lake for that problem, because it's inexpensive and you can hold it there for a while. But then when you do need it, you want to operate on it very, very quickly. So then you need data warehouse-like capabilities, so you can run a very capable analytics engine on top of it, right? And so that's kind of the marriage of that. And sort of shameless plug here, if you're really like into this concept of a lake house, Matej Zaharia and Ali Qudsi, who are two of the and a few other folks who were the founders of Databricks, and Matej being the founder, the person who initially wrote Spark. These guys have written a very cogent set of blog post that describes Lakehouse and goes into all of the gory details as to why it's important. From a security operations perspective, maybe last point on this, from a security operations perspective, what's happening is, and this ties to Janahan's point and Patricia's point, is data lakehouses are not just enabling threat detection. They are now, because there is this ability to layer on machine learning capability because of the openness of the platform, they can turn that capability inwards, meaning how do I enable an analyst to work better from a security operations perspective? How can I learn from that analyst's activities and then improve subsequent analysis in an automated way? That's one aspect. And the second aspect from a privacy perspective is how can I do better data lineage and better understanding of derivative results from a data set, such that I can comply with the user's, in case of GDPR, right to forget, or actually it's right to erasure, which we kind of translate to right to forget in marketing terms. And so those are the capabilities that they're being enabled. But the key point really is, for lakehouses, they're open, and they enable cost and performance improvements, and they enable this ability to execute a lot of analytical power, not just rule-based things, but advanced analytics with machine learning at scale.
Thanks. That's really helpful. Janahan, Patricia mentioned in the last response in terms of edge computing and how privacy plays a role there. In your opinion, what is the role of edge computing in cybersecurity and privacy?
Yeah, so it's interesting because when a while back when before the cloud everything was on-prem, then everything moved centralized towards cloud, and now we're going back towards. I mean, it's not the same as on-prem, but we're moving again to the edge, and it was related to some of the reasons that I stated before, including the reason that Patricia mentioned as well, in the sense that there is that speed factor and the latency factor. There's also tremendous large, as the amount of volumes of data increase, you still have to move data to a cloud. So you still, the networks still have to support that, right? So because of large volumes of data, and you have safety critical applications that require fast turnaround times. Like think about, if we get to autonomous vehicles and there's a threat when a person is driving, and it's basically, the threat is basically on the device itself right there. By the time you actually send the information all the way through the networks to the cloud and come back, things might not look too good, right? So from that respect, mobile, the role of edge computing it helps in that respect of actually doing detections on the edge. That's one of the biggest use cases, detections on the edge. And it also supports, from a machine learning and AI perspective, it supports federated and collaborative AI. So basically split learning, and then MPC techniques, right, for building ML models, for instance, for ITS security, right? Transportation system security and so forth. And you could apply to other applications where devices are more distributed. They need fast turnaround times in terms of detections from a cybersecurity threat perspective and so forth, right? So in that respect, we're seeing that shift right now. A lot of movement towards the edge, and that's why you have, from an infrastructure perspective, you have Kubernetes on the edge. 5G mobile edge compute is proliferating. And there are big data platforms today that actually provide services on the edge. They actually provide the tech stacks to support edge-based compute.
Thanks. That's really helpful. Since this is primarily an AI and machine learning conference, I think it would be interesting to discuss what are some challenges in applying AI or machine learning to cybersecurity and privacy. This is to all panelists. I think Monzi, please feel free to take the lead.
Sure. Thank you for the question. I would like to break it into like 3 different pieces. I think the first piece is really around people, where there is a sort of a gap in competency to overcome, where most security operators are not data science and machine learning savvy. So the capabilities that they may have access to, they don't know how to use them. And then there is a split problem on the other side of it, where people who are data scientists who have competency in machine learning disciplines don't have the cybersecurity domain expertise. So that's a big challenge to converge these 2 things. And what we're seeing in a lot of customer environments is they're pairing data science people and security operations people in the same pods in their work function. So that's one thing that's happening. The other challenge for cybersecurity and machine learning is, frankly, as being part of the industry, as a product builder, what's happened in the past is we've kind of done a little bit of disservice to the community, where ML and AI was the product was not up to the hype. And so now when I oftentimes talk to customers, they're like, don't talk about machine learning, don't talk about artificial intelligence for security operations. We tried that 5 years ago, and it was a pot of goo. So it was no good. And so now the technology and the maturity is catching up, and now there is real relevance here. But now we have sort of that social aspect to overcome. And the third thing that I would say is, from the manufacturer's point of view, product developer's point of view too, is we kind of have a responsibility, where we and from a machine learning expertise point of view as well, we have a responsibility in that we really have to demystify things for the security operators and make it relevant in their terms. So instead of talking about regression and clustering, we can talk about anomaly detection or reducing false positives, so that we can actually start to speak the same language. And there's nothing to speak of when we start talking about, get super fancy with neural networks and ensemble models, and it's all buzzword bingo from a security operations mindset.
It's very helpful. Thanks. Janahan, would love to hear your thoughts on this.
Yeah. So how previously I said, we need large amounts of data and all that other stuff. That's true, but we need to also know what the data is actually telling us from a perspective of what's good and what's bad. So unlike other industries and other disciplines where you can apply machine learning because you have all your data sets in terms of let's look at the basics from machine learning, right? You have a bunch of data that basically aligns to a certain aspect, and then you want to identify whether it's an anomaly or whether it's a certain pattern or a certain object or whatever. You will have you can get that data. You can have access to that data pretty well. From a cybersecurity perspective, if you want to identify the bad and the good, we have a lot of good. What about the bad, though, right? And that's one of the issues that we see. Like, how much of bad can we get access to? Because the bad has probably already caused us damage anyways, right? How much bad do we have access to? So basically, what we're seeing a problem here in terms of the actual application of big data analytics to cybersecurity is basically imbalanced data sets. We have data sets where, let's say there was, we caught a threat, a brand new, let's say on the network, we saw some communication of data that occurred. That would be one in terms of, one among tremendous amounts of data. So we have an imbalanced data set there. So I mean, there are ways to go around that. You can do oversampling. You can oversample the bad, undersample the good, and you can do synthetic data generation. Like if you want a bunch of good, or maybe even come up with your own data for bad. So that's one of the issues that we see there. The other thing is also that most of the data is unlabeled, right? You need labeled data if you want to do supervised learning. We get vast swaths of data, some of which are partially labeled, in which case you can use semi-supervised learning. You can do unsupervised learning on unlabeled data for anomaly detection, but then it's only anomaly detection as opposed to any other form of ML-based analytics that you want to do. Of course, you can then perhaps do even peer group analysis, so applying application of analysis across peer groups. And then last but not least, because of this, because of all what I described, false positives. False positives can be devastating, not in the sense of the damage it can do, but in terms of the cost and all that you put into when you have tremendous amounts of false positives. So if you take a look at it from a cybersecurity organization that actually does provide cybersecurity services, if you have tremendous amounts of false positives, you can imagine what the SOC and so forth go through, right? So for false positive, what the industry basically tries to do here is you wouldn't use a single ML model-based detection mechanism. You try to correlate it across various ML-based detection mechanisms that basically detect from different dimensions, correlate across the dimensions to increase the probability score and thus reduce the false positives. So this is where the challenges we face with big data and its application to cybersecurity.
Very helpful. Thank you so much, Janahan. Patricia, your thoughts?
Those are all great thoughts. I would emphasize what Monzi said about people being very skeptical about AI and how well it could perform, and not understanding how far it came in the last 2-3 years even. We'll get people who, for example, are still more comfortable having humans do the work rather than AI that can outperform them. So one way that we've gotten around that is by having a demo on our website where people could try out our model right off the bat, and that actually delivers a lot of a very good proof point that the model can outperform humans and takes away a lot of that skepticism. So as an AI company, if you are struggling with this, I would recommend, putting yourself out there as much as possible, taking those risks of maybe some people will try some data that won't work with your model, but if your model is actually very good, the vast majority of people who try it will be impressed. And latency is actually something that comes up a lot. A lot of people are very concerned about the latency of AI. And I'd say that's another huge problem to adoption, the cost as a result. So if a lot of companies don't really fully understand machine learning operations combined with a machine learning model optimization in a way that will reduce the latency to a point where it's actually affordable for their customers or for themselves to run these models on their cloud using enough GPUs to go through terabytes worth of data in a small amount of time. So there's this really big gap in knowledge accessibility when it comes to serving these models and making these models operationally fast. And lack of data, as Janahan mentioning as well. With a lot of sensitive information, it's very difficult to get permission from the users to train your machine learning models on them. It's also very difficult to find annotators that you can trust with that data that are affordable. It's difficult to find the data in the first place. So for example, when you're trying to identify credit card numbers, a lot of people do just go with regular expressions because that is the easiest thing to do. And you're not going to be able to find that in the wild very easily. But then if you do find a dump of credit card numbers, you might not be allowed to use that because it's sensitive information. So it's really tricky when you're dealing with private information and you're trying to use AI on that data.
That's excellent. Thank you so much. Last set of questions. So Janahan, one question from you is, we've been talking about big data. We've been talking about a lot of data coming in, running complex analytics on top of that. In terms of SMBs, which are a backbone of our economy, they might not be equipped for all of this. So for SMBs, what is a viable cybersecurity strategy in your opinion?
Yeah. So as I had mentioned before, right? SMBs are a path of least resistance for hackers. They're the best because in the sense of, SMBs don't have dedicated security teams because, they have smaller budgets. The company's never set up with security in mind, and data. And the other thing is data breach and ransomware attacks can be devastating for the business. I mean, they can pretty much shut them down. That said, almost I think 98 to 99% of the businesses, both in US and Canada, are SMBs. They contribute almost, I think, somewhere 40 to 45% of the GDP to both countries. So the best strategy for an SMB is to basically go with a managed security service provider. That's in my opinion the best strategy, because you basically want to outsource, just like, okay, from a physical security perspective, if you look at banks, if you look at apartment complexes, if you look at malls and all that, the security guards, the security cameras, the alarm systems and all that, it's basically outsourced. It's a different, the SOC associated with all that, it's all outsourced, right? In a similar way, cybersecurity should be outsourced for those that for SMBs to a managed security services provider, and they should get the gamut of services from them, all the way from security hygiene, security posture management, security posture assessment, managed risk, managed detection and response. All the from a managed detection and response, it'll have all the behavioral analytics and big data analytics that the actual managed security service provider will perform using the data lakes, the SIEMs, and the automated orchestration and response systems that they have. And in a way, it works from an economy of scale perspective as well, because as long as the MSSP has a number of customers, including the SMBs, the cost is viable for an SMB. But at the same time, from a cybersecurity perspective, the greater visibility an MSSP has, which is why you should go to an MSSP that has many, many customers, is because they will be getting data from all those different customers. And if they were smart and were doing big data analytics with a cybersecurity data lake, they would be basically enhancing their analytic systems to basically improve on their detections and cross-pollinate across all their different customers to basically help with the threats and protect all their customers equally. So basically, whenever they see a threat or identify something on one customer, it automatically gets applied. Any remedial action or patching or whatever gets applied across all their customers. So that in my opinion is the best strategy to be pursued by SMBs.
Very helpful. Thank you so much. Monzi, with hundreds of terabytes of data headed in our direction, how close are we to detecting threats in real time?
It depends on the threat, and it depends on the kinds of techniques we want to implement. I think some techniques are well suited if an organization leverages a lot of threat intelligence, and it's essentially driven through streaming enrichment and alerting, that those are well implemented and well understood problems. There are a variety of different technologies out there, including Databricks, that enable customers to accomplish that goal. There are other technologies, or there are other types of threat detection which, by their very nature, require a longer window of time because the attack itself, it's transactional. If I use sort of an overly naive example, of a stolen credit card that is being used on a retail website, for example, right? And so somebody has a stolen credential, they have a stolen credit card, they log in, they go through a series of steps, and that might take 2 seconds, that might take 5 minutes. And so in that case, the sort of the notion of real time sort of changes, right? And so you have to aggregate that information to really say, well, is this transaction a normal transaction or not? So some types of, and that's, going back to the whole use case concept is, what are you trying to protect yourself against, and then appropriately choosing whether that's a streaming use case, and that's why I don't like to use oftentimes the word real time. Is that a streaming analytics use case or streaming detection use case, or is that a batch detection or a batch investigation use case, right? So that's how I would ask people to start to think about how to rationalize that information.
That's very helpful. Thank you. Patricia, one question from you. It seems like security, we have gigabytes and terabytes of data, but there is need to get more and more data. If you want to make informed decision, for instance, for a failed login, we want to provide that analyst with as much information as we can, such as where the location where this login was from, some more details about the person, the machine that they were logging in. And a lot of these, while they improve the security posture, and I know you said that security and privacy are married, but looks like a lot of marriages, there seems to be some friction over there. So how do we resolve this where security wants more data, often personal information, which while it's privacy, of course, it's happening at SOC, but can we come up with techniques to solve this challenge?
Yeah, it's a great question, Hassan, and really funnily put. So in a way, yes. So you can query a database that contains this information and redact as much personal data as possible before returning that information to a particular user in the security team who's trying to determine what went wrong. And the way that you could redact it is by saying, instead of having the credit card number there or the name there or somebody's birth date there, having the fields that are identified as such. And that already adds a really good layer of privacy for the users. In particular, if you're dealing with structured data, you could grab the names of each of the fields that you're dealing with. You'll know that it's names and credit card numbers. You might have note sections where things are unstructured, and you can then run redaction on that. But for the most part, you're good. You could just get that information separately and do unique counts and things like that. But if you're dealing with unstructured data, that's when this comes handy. And that should give a security team enough information about how many unique credit card numbers appeared in a particular set of unstructured data, because it's possible to do that in the back end. How many unique names appeared, also possible to do in the back end. So definitely a solvable problem, but probably not one that's been solved yet.
Thanks. That's very helpful. I'm just going to take two questions that I have in the chat. I think this one is very appropriate for Janahan, because you talked about how going to a larger MSSP solves this problem. So Nasran asks, could you elaborate on what kind of shared information between organizations helps with cybersecurity?
So from an MSSP perspective, shared information across, okay, so let me interpret the question as if an MSSP basically sees information from one of its customers, with regards to threat information or something that helps with threat intelligence or so forth, or even an analytics or some form of analytics-based, behavioral analytics-based detection that they have detected or that they've created for that organization that was basically, say, under attack or attacked, that information, of course, anonymized to the extent so that only the poison is taken out, not the actual identity of the organization. For an MSSP would definitely want to identify that poison and make sure that the cure for it, whatever it is applied across the other organizations that it provides services to. So it's not about sharing information across those organizations directly. It's about whatever you see here that's bad and that you have a way to fix, that you would be basically sharing with the other organizations, again, without stating which other organization actually went through that.
Very helpful. Thanks. Jennifer's got a question. I think, Monse, you might be well equipped to answer that. Jennifer says that with the recent outage from Google Cloud and Facebook infrastructures, could you share some insight about final destination of clouds for businesses? For instance, could it be a multi-cloud or hybrid solution?
Yeah, if with your permission, Hassan, I actually want to pile on to Janahan's comment for just 1 second on the data sharing bit. I'll keep it very brief. Is we see 3 types of data sharing requirements from customers when it comes to cybersecurity. The first one is around threat intel sharing. So these are specific things about bad actors, bad domain names, bad IP addresses, etc. The second thing that we see requirement for is analytical sharing, how to detect something or how to auto-investigate something. And we have some examples of that in blog posts and things. And when I was at Splunk, we did a bunch of work around this kind of work so that people can have open access to analytical capability. And there's actually an open platform called Sigma, which is an open specification as well. So if you Google Sigma threat detection, you will find information there as well. And the third kind of data is actually the kind of thing that Patricia was talking about, which is actually missing in the community, which is actual data from threat scenarios or data from environments where people are comfortable sharing it. Whenever we have these meetings with chief information security officers, and I ask around the room, I said, how many of you would like somebody to share their data with you, like somebody else to share data with you? Everybody raises their hand. And then I say, okay, how many of you are willing to give your data to somebody else? Nobody raises their hand. And so that just reminds me of the old blues song that everybody wants to go to heaven, but nobody wants to die. So so those are the 3 different facets. And I think all too often when we think of data sharing cyber, we fall on the third one, but we forget that there's these other 2, which are anonymized essentially. And they can be very, very valuable. So thank you for that segment, allowing me to address that. Now moving to Jennifer's question on destinations. I mean, what we're seeing is more and more customers want to store their data in the cloud. And the reasons for that is there's cost benefits and then there's elasticity benefits. And then there's also sort of this erasure benefit where you really just like push a button to delete things or to kill your instances rather than having to get rid of hardware, which is a much more onerous process if you had that information. So it does make things operationally simpler and also from a cost effective perspective. So hopefully that was the spirit of the conversation that you were going for. If not, then I can elaborate more.
I think that appropriately answers it. I think we're over time. Thank you so much. This was very insightful. I really enjoyed our conversation. Thank you for joining.
Thank you for having us. Yeah.
Thank you.
And if somebody wants to ever find me, I'm really easy to find. I'm Monzy, M-O-N-Z-Y at databricks.com. So happy to geek out more as time goes on. Thank you, everybody.
Thanks.
Thank you.